Welcome to my channel. Please don't forget to subscribe, like, share and comment. In this math tutorial, we are attacking a problem in analytical geometry. Now the question reads, in the diagram alongside the points P minus 6, 4, Q minus 1, 3, R 2, 0 and S 0 minus 2 are given. PS is parallel to QR. Now we are required to find the length of QR. So that is A. Calculate the length of QR. Now we are going to use the distance formula to calculate that length. And the distance formula is given by D is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So we just need to assign x1, x2, y1, y2 on these points. So we are going to say x1 is that point and y1 the corresponding, and we have x2 and y2. Okay, so that it will be easy for us to substitute. Then we are going to say now the line QR is a distance given by QR is equal to the root. X2 is 2, so that's 2 minus 1. We square that. Then we say plus y2 is 0 minus 3. We square that as well. All right. So we're going to say now QR, the length, is equal to the root. 2 minus 1 is 3. 3 squared is 9. So you have a 9 there. Plus 0 minus 3 is minus 3. We square it. You get a 9. Another 9. So we are going to get the root of 18. But now you remember from the laws of sets, we say this is equal to root 9 by root 2. And that's going to give us 3 root 2 as the answer. Now, therefore, we say QR is equal to 3 root 2. And these are units. All right. We've finished the first part of that question. Okay. Now, let's move on to part B. All right. Part B requires us to calculate the gradient of QR. Now, we know the formula for the gradient. M is given by y2 minus y1 over x2 minus x1. Now we can do what we did up there. We know Q is a point that is given by minus 1, 3, and R is a point that is given by 2 and 0. We just assign those variables. We are going to say this is x1, y1, then x2, y2, right? Then we're just going to substitute this into that equation. But now that gradient has to have a name. We are going to call it MQR. So MQR is equal to y2 is 0 minus y1, that is 3. So 0 minus 3 over x2 is 2, 2 minus x1. So that's 2 minus 1. And that's going to give us minus 3 over 3. And that's equal to minus 1. All right. So we've managed to find QR, the gradient of that. So we're going to say M, therefore MQR is equal to minus 1. Now we are going to do the last part of this question, and that is C. Now we need to find the equation of the line PS. All right, but we are given that PS is parallel to QR. So when these are parallel, that means the gradient of PS, we can say MPS is equal to MQR, and that is equal to minus 1 from that part. All right. And we know there's a point there and that point is actually S0 minus 2. So I'm going to take S0 minus 2, S0 and minus 2. We're going to use that point. Okay. How do we find the equation of that line? We're going to say y minus y1 is equal to m, the gradient, that is the gradient of PS, times x minus x1. All right, so we're just going to take any point on the line PS. So in this regard, we are taking S0 minus 2 as the point. Okay, now we're going to say y minus, let's call this one y1. So that's minus 2 is equal to m. You remember we found our m is minus 1. Then x minus, we get a 0 there. Okay, so I'm going to say y plus 2 is equal to minus x. Therefore, the equation of that line is given by y is equal to minus x minus 2. We've come to the end of this question. Thanks for watching. Please don't forget to subscribe, like, share, and comment. Enjoy your day.